And we have one more talk, and then we're gonna wrap up our afternoon before Apero with the final panel. So our next speaker is Mariela Tanchez. She is coming from IoTeX, and she is a senior business development lead with the topic of an open ecosystem for real-world AI.
Thank you so much. Hey guys. You probably saw Simone, our DevRel lead in the schedule. Unfortunately, he had some family issues, so I'm covering here. So maybe not as technical as a presentation as you would expect, but at least I give you the real world perspective, which I think also, I know, I'm gonna make it quick. I know we're all tired. I'm the last one, not the best timing, but I think it's a great wrap up. What I'm about to discuss actually touch base on a lot of issues and problematics that other presenters have presented today. So very excited about that. So yeah, let me talk a little bit about IoTeX, what we're trying to solve, and also like where we're going with AI and how it all kind of comes back to DePIN. So yeah, in context, AI meets the physical world, right? When we think about AI, we think about it digitally. We think it in a cloud, AI agents, language learning models, but we never really correlate it with the real physical world. And that's why we see a problematic and we see a need. And that's why at IoTeX, we're developing tools to kind of solve this. So the challenge is that right now all AI models are trained with historical data, right? It's not actual real-time data. It's data that they have been fed from other sources from past times, but it's not on time and on demand, right? So to maximize its true potential, AI needs real-time data, right? And this is where the physical world needs to get involved. And how do we involve the physical world? With DePIN, right? And I'll dive into it in a little bit. As you probably heard it, data is the new oil, but not all data is equal, right? You need to have the 6 parts to make sure that the data you're feeding into AI can be trusted and it's actually can be used in a source that is relevant. So one time you need real time. You need continuously refreshed. The data from yesterday is no longer worth it in today's world. It already changed from yesterday to today, so you need real time. You need verifiable. You need to make sure that it's signed, that it's traceable, that it's trusted, that you can actually use that data and the data is correct. You need real world with untapped data sources, meaning that nobody can tamper with and you have the actual data as accurate as possible. You need contextual. Data without context is useless, right? I can put same data in different contexts and it's gonna provide me different outcomes. So you need to make sure that the context is accounted for. You need diversity to make sure that the same points of data can be replicated in different scenarios, but you need that diversity to be inputted. And of course, you need complete. Parts of data are not worth it. You need a complete, a time series of history of data. So creating high quality data is a collective effort. And we need to think about it as a society and how we can all kind of contribute to this. So this is what we're trying to build at IoTeX. The market opportunities here, we're actually quite excited. We've been planning this for a while, you know, even since the inception of our project. This has been part of it, but we never kind of push it too much, and also we weren't ready, and I'll explain to it later. But this is the time to actually get into the AI. The market opportunity is there. Right now we're at a 370 billion market opportunity, which is estimated to be 2.4 trillion by 2032. So if you're not in data or AI, now is the time to get in. Yeah, the fastest growing segments, as you can see, is real-time analytics, AI data management, and domain-specific AI agents. So how did we get here? IoTeX, we've been, for those of you who don't know us, we're an L1. We were founded in 2017, and we launched our EVM and L1 blockchain in 2018. And that way we have blockchain native devices. So we were trying to figure out how real devices can connect their data to the blockchain. We launched, for example, a home security camera, which encrypted your data, and only you had the keys to decrypt the data. That camera won several awards, and it was our first step to understand how to really connect the devices directly to the Web3. We also had our Pebble tracker, which is a small device that you can use it to count steps or have accurate GPS data. You can put it in cars, etc. So it's just a couple of POCs that won several awards because of the way that we understood how to manage the data directly from devices in a secure and private manner, but also so it became trusted. Because before, you used to always use a cloud server, and unfortunately with that, you can get tampered data. So by doing directly data from devices to the blockchain, you get untampered data, which is what we achieved. Next is, okay, we already kind of understood how to connect devices to the Web3. But then we kind of understood there's privacy problems, there's data problems in the sense that devices are the biggest amount of data that they can produce. So as has been mentioned before, you don't need to put all this data on chain. It's not worth it, it's very costly, and probably you don't need all this data on chain. So we understood it. So we started working on different modules. One was, for example, privacy, right? We're handling home data, we're handling car data, we're handling energy data, and a lot of sensitive data that needs privacy. So in this sense, we understood that we needed a CK module to make sure that all this data is being processed by machines without being stored, but providing proofs that will generate a reward or an incentive. For example, one of my best, and I've told some people today talking with you guys, but for example, insurance companies, they want to provide a reward for you driving the car 5,000 miles without a crash. Oh, it went away. Okay, it's coming back. So yeah, basically, they don't need to know the model of a car, how long you've driven, or anything. So we created also like a module core for off-chain compute. So this module, what it does, it reads your car data constantly, all the time, and only when you get to 5,000 miles, it's gonna grab that piece of data and wrap it up in a CK proof and put it on chain so that the company, the insurance company, can issue the reward, which could be a discount for your so that anybody could, thank you, deploy a DePIN project. So within our modular DePIN infra, you can actually go in and choose the part of a tech stack that you want, whether it's privacy, whether it's governance, whether it's off-chain compute, and just pick the part that you need to build your DePIN project. And this is blockchain agnostic, even though we do have our own chain. It's blockchain agnostic, so you can connect it to anyone. So okay, so we got the first, okay, devices to the blockchain, then kind of managing the data. Now we have the data on chain. What do we do with it? And that is where chapter 3 comes in, which is our real world AI stack, where we grab all the data and make use of it. Because what's the point of having all this data if you're not actually using it, right? So why is this moment important? We are looking from LLMs in the cloud to real agents in the real world. Right now, we have autonomy in cars, we have robotics, we have so many autonomy coming on from machines, machine-fi economy, as we call it internally, that the next frontier is AI agents, intelligent systems. They make decisions, they operate in real time, they're actually autonomous. But for this, you need a very good and secure system and structure for it. So our vision is an open ecosystem for real-world AI, where anyone can contribute data and anyone can consume intelligence. There's so many points of data when you think about DePIN. There's sensors, there's cars, there's traffic, there's weather, there's energy usage, etc. And everybody can say, yeah, I have this data, I have this data, I have this data. Okay, but how are you presenting it to the people that need the data? And this is where we're kind of being that middle layer to make sure that we're organizing this data, aggregating the data, because sometimes you'll need different data. For example, for a car route, you're going to need traffic data, but you're also going to need weather data. So it's not enough for you to just grab the data from one point. So we're aggregating this data and feeding it into an AI language learning model so that different parties that are interested, and I'll share a couple of use cases later, can use it, and it's easy for them to use it, right? So yeah, we are creating our tech stack overview, which is a modular, scalable, and decentralized foundation for the future of real-world AI. Which I'm going to show you guys next. So yeah, it's based on 4 pillars, right? One is ID. You need to make sure that the machines are verifiable, that they're accountable for, and that you are not adding bad actors to the ecosystem. So you need to make sure that they're properly identified. So this is our ID. Quicksilver, actually, I'm going to explain this point by point, but these are the 12 pillars. Our AI real-time context, our fields, and our registry. So yeah, the first part, ID, like I mentioned, you need to make sure we assign verifiable identities on chain to make sure that it's authentic, that it's actually the device you're talking about, and that the actors are real and not bad actors. And also, for AI, it's very important that you know that the source is trustworthy. So with ioID, you can ensure that the source is trustworthy. Then we have Quicksilver, which is our open language learning models. And what's interesting is that it not only aggregates data, but it also proves its provenance and integrity. So Quicksilver, our idea is to grab all this open data that even though projects are using it for specific use cases, they're not putting it out there for a lot of more use cases that can be, for example, prediction markets, the US stocks, where they need actually all this data that can be fed by DePIN devices that is not being used. We want to aggregate it in a way that's easily digestible by any financial company, enterprise level company, and that it's easily accessible and you don't have to work out a whole system to provide it to them. The realms, as we call them, they're contextual knowledge bases. So we have different realms to feed and train our AI models. So basically, depending on the realm, it could be a mobility realm where we're aggregating data from weather, from traffic, from sensors and parking spaces, etc. So we're trying to keep also like this division of realms in there. And then our pillar number 4, it's our EVM chain. Obviously, at core, we are an L1 made for DePIN devices. We were made with fast instant finality and very high throughput. Even from the start, we were at 1500 TPS. Right now, we're at 2000 TPS with instant finality. So we want to make our L1 is actually made to handle all the device that comes from data. So yeah, our idea is to come from physical intelligence to on-chain economies and kind of be that middle layer that connects all of them. So we want to aggregate the data, and tokenize that data, and then monetize all the intelligence that's coming out from DePIN devices and all this data that we currently are holding and grabbing, but not really using to its maximum potential. So I'm just gonna finish real quick with one example realm, and this is actually something that we're in the works with some companies, but mobility intelligence, right? So you have your real-time vehicle data, which it could be GPS, right? Let's say, for example, if you want more specific, you can have an on-a-coin device. You have speed, right? If you have a demo device connected to your OVM software. You have traffic. There's projects like 375 AI that have sensors in different highways, and they're monitoring traffic. And different sensor streams, whether it's in cars, in highways, and everything. So you aggregate all this data, and then you make sure that it's verified and trusted by Quicksilver, ioID model, to make sure that you're getting the right data. And then you aggregate into the mobility realms for AI agents to make better solutions. So this could be a safer and more efficient autonomous transport. And this is our end goal and what we're currently working on with some companies. As a very low level POC, low hanging fruit, we're also working with distribution companies that have logistic fleets for them to make better routes decision by aggregating all this data and have a little bit more of real-time data than just your average Google Maps, Apple Maps, and traffic data, but real-time data of how they can better manage their routes and their fleets to work a little bit better. So yeah, this is kind of just how we see it happening from here in a more autonomous kind of world. And yeah, that's pretty much it. If you want to connect with us, that's our social media, and you can also connect with me directly if you have any questions. Yeah, thank you so much for taking the time for being here. And I'm sorry I was the last one, but thank you for being here and paying attention.